Okay, let's take a look back at our third question. Which is the more effective course design? Did you pick A, where we focus on one single topic at a time, or B, where we mix up our topics and jump back and forth? Before I give you the answer, I want to tell you a quick story. I frequently teach a research methods course, and years ago I got frustrated with the textbook I was using. I noticed that it would often introduce a concept in an earlier chapter and then elaborate further on that same concept later in the book. I thought, how confusing for students. Why not put all of the information for a certain concept together in one spot so that when students first encounter it, they get the full story? So I went on to use different course materials so that I could organize the topics so that everything to know about a given topic or concept would be presented together at the same time. Well, it turns out that I was wrong. Research shows us that mixing up the topics leads to better learning. This is referred to as the interleaving effect. Mixing related learning activities and topics supports long-term learning and supports transfer to new contexts. But this is so counterintuitive, right? Who would think that you would learn better if you jump around from topic to topic? Well, the counterintuitive nature of this effect has actually been documented empirically. In this study, participants learned painter styles in block sessions, where all paintings by a particular artist were presented together, and in interleave sessions, where all of the paintings by all of the artists were mixed together and presented in an interleave manner. Participants got a chance to experience both types of sessions. Despite better learning with the interleave sessions, when asked, participants still reported block learning as helping them to learn better. So, despite interleaving being helpful for learning, it doesn't always feel that way. Students will likely tell you that they prefer to block topics, and interleaving is a more difficult way to learn. But it is more difficult precisely because deeper learning is taking place. Reasons why interleaving works are a bit complex. Let's look at a couple more studies to get a sense of how interleaving helps with learning. In this study, participants were asked to learn formulas for calculating volumes of geometric shapes. There were 4 different solids to learn about, and participants were given one tutorial for each solid, so a total of 4 tutorials. For each tutorial, there were 4 problems to be solved. Participants were broken up into 2 groups. One group was called the blockers. The blockers would be given one tutorial and then the 4 problems that went with it, then the next tutorial and the 4 problems that went with that one, and so on. The other group of participants was called the mixers. Mixers received all 4 tutorials at once, and then all 16 problems in a random interleaved order. During the initial phase, blockers solved on average 89% of the problems correctly. Mixers actually performed worse. Only 60% of the problems were solved correctly. However, 1 week later, both groups were given 8 new problems in random order. Blockers only performed at 20%. Mixers were at 63%. So what do you think happened here? What did mixers learn that blockers didn't? Let's go back to how each group was taught. During the initial phase, blockers were given a tutorial on the formula to use to calculate the volume of a cone. Then, blockers were given 4 problems about cones to solve in which they needed to apply a cone formula. They didn't need to think about what was the most appropriate formula for solving the problem. They didn't even need to think about the nature of the problem or the formula at all. All they needed to do was to plug and chug. Then they would move on to the sphere tutorial and do the same thing. However, when the mixers encountered a problem, it wasn't obvious which formula applied to the problem. They really had to think about the nature of the problem and what a given formula accomplishes in order to successfully solve the problem. They had to know how one formula differed from another, what features of it made it unique from the others, and perhaps also which features all of the formulas share in common. Blockers didn't need to do this, so in this way, mixers actually developed a richer representation of each formula, a deeper understanding than the blockers. So we can see here that the benefits of interleaving support not just long-term retention, but also a deeper, richer understanding that ultimately contributes to the ability to transfer what is learned to new problems and situations. Let's look at another study. In this study, children practiced throwing beanbags at a target on the floor. Unlike the children in this picture, their vision was occluded at the time of each throw. Half of the children did all of their practicing throwing to a target at a fixed distance. For the 8-year-olds in the study, this was at 3 feet. The other half of the children threw to targets that were either closer or further away. After the learning sessions and a delay, all children were tested at the distance used in the fixed practice condition, the 3 feet mark for the 8-year-olds. Now, which group would common sense tell us would do better when tested at 3 feet? Common sense tells us that the children who practice at the tested distance would perform better at that distance, right? But the complete opposite was true. The children who practiced closer and further away actually did better when tested at the 3-foot mark, which they hadn't practiced, than the children who practiced at only the 3-foot mark. So what this study really emphasizes is the benefit of variation. The children in group 2 likely learned something about adjusting the parameters of the motor program that corresponded to the throwing motion, and that outweighed any benefits of being tested at the practice distance. They basically developed a more flexible movement vocabulary. When we are learning something new, changing the parameters of that thing we are learning and getting feedback about what happens when those parameters change gives us a much richer, deeper representation of what we are learning, just as we saw in the previous study with the geometrical shapes. There is so much value and information in seeing how something can vary. So we have seen how interleaving aids in the ability to discriminate concepts. And those discriminating features contribute to a better understanding of what we are learning about. Also, we have seen how varied practice improves the ability to transfer learning from one situation and to apply it successfully to another one. The mechanisms underlying interleaving, what makes it work, are tricky to understand. I'm hoping that an analogy here can help to illustrate how having variation, having something to compare and contrast with what we are learning about, helps us to learn it better, to provide a broader context, a richer understanding of what is being learned. So you may have heard the expression that the fish is the last to know that he is in water. Why is the fish the last to know he is in water? Well, in order to learn what water is, one needs to know what the alternatives are. For example, how does a fish understand what wet is? Wouldn't it have to know what dry is? If a fish has never experienced anything other than water, how could it really notice it or understand its properties? Knowing alternatives gives us the opportunity to observe similarities and differences, to observe characteristics that we would otherwise take for granted. Another example is with language. I remember in my younger days being over at my German friend's house. My friend and her family mostly spoke English in the home, but they also spoke German. That day, my friend's little sister also had a friend over, and the two of them were listening to a song in German. I remember asking the little sister's friend if she knew German, but she had no idea what I was talking about. She only knew English and had never before been exposed to another language, so the very concept of a language was too much for her to grasp. Even though she was very familiar with one example of a language, she wasn't able to recognize it as a language because she had never known anything different. This is why interleaving works. By being exposed to other related concepts, we come to better understand what we are learning because we are made aware of what features the various concepts have in common and what features make each unique. Okay, let's talk about how we can apply interleaving to the classroom. First of all, don't totally remove blocking. There is something to be said for having sessions of solid focused attention on a topic or concept. Just be sure to add in interleaving. It's the returning to it within new contexts that really matters. The easiest way to implement interleaving is to be sure to return to course concepts multiple times throughout the semester, both during class lessons and in assignments. Each time you do this, students will see that concept in a new light because of a change in context, a change in what the student has learned and has come to understand. Also, absolutely point out to students when an earlier concept from the course relates to current content. Don't assume students see that connection. They usually don't. You need to help point it out for them. Make your tests and assignments cumulative, meaning that they incorporate earlier course content. Students hate cumulative tests because they are hard, but that hard work is a reflection of students learning effectively. It is hard precisely because there is so much more to learn that way. Consider providing students with an agenda or a preview of what's to come. This helps to provide some of that larger context up front. When students then encounter those concepts or topics, they will have a better understanding of how they fit in the larger scheme of things, how they are going to relate to everything else to be learned. Have you ever heard, recommended, or noticed that before reading a long paper or chapter or a book, it can really help to first skim all of the headings and subheadings, look at the tables and figures, glance through the table of contents if there is one. Doing this gives you a good sense of what to expect from the reading, which can really facilitate understanding as you go through the reading. This is interleaving at work. Finally, provide variation whenever possible. Even when you are illustrating a single concept, provide lots of examples so that students can see what all of those examples have in common. Being able to notice similarities is just as important as noticing differences. Remember the beanbag study? Even though the kids were being tested at 3 feet away, practicing at other distances facilitated their throwing at 3 feet away. See if you can come up with at least one other way to apply interleaving to your own classroom before moving on to the next video.